Now this question says that there is a wall 15 meters long, 30 centimeters wide and 4 meters high, which is made up of bricks, each measuring 22 centimeters in length, 12.5 centimeters in breadth and 7.5 centimeters in height. If 1 by 12 of the total volume of the wall consists of mortar, how many bricks are there in the wall? Well, first of all, realize that the question talks about a wall which obviously is cuboidal and its length is given as 15 meters, breadth as 30 centimeters and height as 4 meters. So one catch in here which is very evident is the difference in the units, isn't it? Let's convert everything into centimeters because when we don't do that, we can't proceed ahead with calculations. Meters, as I said, 1 meter is 100 centimeters. So your length becomes 15 into 100, that is 1500 centimeters. And your height becomes 4 into 100, that's 400 centimeters. Your breadth is already in centimeters, that's 30 centimeters. The space occupied by mortar on the wall, which in other words is volume of mortar, is what? 1 by 12 of the total space on the wall. That means 1 by 12 of the volume of the wall. Right? Further next, space occupied by all the bricks. I don't know how many bricks are there. That's what we have to find. But space occupied by the bricks will be what? Total space available on the wall minus space occupied by mortar. Right? That means volume of the wall minus volume of the mortar. That means volume of the wall minus 1/12 of volume of the wall. Right? Which in the next step gives me what? 1 minus 1 by 12, that is 11 by 12 times volume of the wall. So now that I have this with me, realize the wall was cuboidal. So let's plug in the values. Length into breadth into height gives you what? It gives you 1500 into 30 into 400, which is simple calculation comes out to be 18 into 10 to the power 6 centimeter cube. Plug it in here and you have 11 by 12 times 18 into 10 to the power 6 to be equal to space occupied by I don't know how many bricks. Now understand, let's try to decode this left hand side. Suppose there are n bricks being used, okay? We have to find this number n. All these n bricks are identical and they all are cuboidal in shape, right? If we calculate space occupied by one brick and multiply that by n, we will get space occupied by n bricks. Isn't it? That's pretty simple argument. That means what we'll do here is we'll calculate volume of one single brick. That multiplied by n will give me volume of all these n bricks. And that is what is my left hand side. What is volume of one brick? We have the length, breadth, height given in the question for one brick. Multiply them and you get its volume. So well, 22 into 12.5 into 7.5 will be the volume of one brick. Multiply that by n and this is your left hand side. So in this equation you have just the n unknown. So you can write n equals 18 into 10 to the power 6 into 11 by 12 whole upon 22 into 12.5 into 7.5. Let's perform this calculation. It looks pretty tedious, but trust me, it's very simple. So let's begin. 11 into 1 is 11, 11 into 2 is 22. Then we have 2 into 1 is 2 and 2 into 9 is 18. So what we got is 9 into 10 to the power 6 upon 12 into, well, let's get rid of these decimals. So we have 125 here and I'll multiply that by 10. And again 75 here, so again a 10. So the numerator happens to be 9 into 10 to the power 8. Right? What is the next step? Well, again, 3 into 3 is 9, 3 into 4 is 12, and 3 into 1 is 3, here 3 into 2 is 6, carry over 1, 3 into 5 is 15. So what you get is 10 to the power 8 whole upon 25 into 4 gives you 100 into 125. So well, in the next step, this 100 rules out and the numerator comes out to be 10 to the power 6. So you have 10 to the power 6 by 125, which is very simple. The answer is 8,000, isn't it? This is how you get n equals 8,000. That means number of bricks used in here are 8,000 in number. Got it? That's your final answer. Let's recall what we just did in this question. So in here we were given the dimensions of a cuboidal wall made up of bricks and mortar, and we needed to find the number of bricks used. We first observed that volume of bricks used is equal to total volume of the wall with mortar minus the volume of the mortar. But the volume of bricks was nothing but the number of bricks multiplied by volume of one single brick. So we plugged in the values and found the number of bricks used to make the wall. So the flow is equate volume of bricks with volume of wall minus volume of mortar. Rewrite volume of bricks as n multiplied by volume of one single brick. Find n and you're done. Let's see what comes up next for us.